Saturday, September 13th, 2014. Milo had asked for an update on the electric motor module. I guess I haven't posted one for a while. We have the 9-inch Netgain Warp, Netgain Warp 9, series DC motor. Connections are up top here and off on this side. It is coupled up to a CAN EV aluminum motor adapter, transmission adapter, and then there's a coupler that goes from the motor shaft down here to the clutch assembly inside. I've done several videos on that. 5-speed transmission from a 2002 Honda Civic. This is the linkage that I'll be going through in a little bit. Holding the coupled motor and transmission to the frame are not very many things right now. The first is this bracket from Canadian EV. It just bolts around and it goes down to an aluminum crossbar here and another aluminum crossbar that's the back of the motor module. There is going to be, but there isn't yet, a 4-inch square tube on this side, which is going to come out to an L bracket that connects up to these two transmission mounts. And there's another motor mount here, which is another vertical 2-inch tube that goes from a bracket on top and a bracket on the bottom. There's not any adjustment in this one. There's adjustment in here for height, and then there's going to be an adjustment in here for height, just in terms of how many spacers you put in. Going through the gears. So the only way I can really tell is I leave it in reverse. Reverse is a little harder to get into. That makes a noise. So first gear is all the way down and counterclockwise. Neutral position in between. Clockwise is second gear. Back to neutral position and up halfway. Clockwise or counterclockwise would be third gear. Clockwise would be fourth gear. Back to the neutral position, up and top. And counterclockwise is your fifth gear. And then getting into reverse sometimes take a couple of tries. I'm not sure why exactly. It does on my car as well, so it's not a surprise, but I don't know how the linkage is going to work that way. So you can see that this thing goes back and forth, and that could be connected up to just a cable in terms of getting up and down, but to pivot back and forth, I haven't figured out how to do that yet. So for the moment, if you are driving the vehicle that this is pushed in, this is bolted into, you are going to be going back here. I'm intending for this thing to be using second, fourth, and reverse. So if you're going to be going less than 35 miles an hour or so, you're going to come back here and put it in second gear, go back into the car, drive it, and it's just going to be a single-speed transmission. Reverse is annoying because you've got to come back here, get into the reverse, go into the car, back it up, and then come back here after you put the emergency brake on, and then put it into second or into fourth. It's not perfect, but it's what I'm planning because I don't have the mechanical skills to come up with a shifting linkage. So here is the hydraulic connections for the clutch. Depending on who you talk to, they are absolutely required or not required at all for shifting gears. So this hydraulic pushes a plunger. The plunger disengages the clutch with kind of a lever assembly. And then you let go of the clutch, and part of the clutch pedal actually retracts it and takes the pressure off, and there's a little bit of a spring in here, it pushes back. So that's the clutch. Right now I'm not using the clutch. The motor isn't spinning when I'm changing gears, so there's no trouble at all moving from one gear to another. If we were to come up with a linkage for the transmission, I'm not sure how hard or how easy it would be to change from second gear to third gear to fourth gear to fifth gear, etc. I don't really expect we'll be spending very much time in first gear because it tops out at quite a low RPM, or sorry, quite a low speed, somewhere between 8 and 10 miles an hour, I think. And you've got enough torque to start in second gear. I'm not sure if anybody's actually going to use first gear. I forgot to point out, as is probably obvious, I am not planning to connect this for version 3 of the electric motor module. It's difficult to connect the plumbing for the hydraulics, and there is no clutch inside the cabin right now. And if there was, connecting and disconnecting it would be problematic, because you end up having to purge the air out of the hydraulic line. And I'm told it's quite a procedure, although I've never done it myself. For the controller, we shifted over to the workbench. So this is the Netgain industrial controller. It is a commercially available DC motor controller. This is a little older model. I'm not sure it's actually available anymore, but it has several connections. It is rated at 400 volts, 1000 amps. It's actually a very nice controller for flexibility. You supply 12 volts to the electronics. So the electronics inside here that run on 12 volts are fed separately. So there's no DC to DC converter inside that is expecting a certain voltage range. So you can give this thing anywhere from 24 volts to 400 volts to drive a variety of motors in a variety of configurations. It is for prototyping. I think it's going to be very good for me, so that I don't need to use a variety of controllers to test out different voltages of motors and different sizes. You can limit the current to whatever you want. You can limit the battery current to whatever you want. So if the battery pack can only supply 150 amps, then that's all that you take out of it, and you get the performance from your motor depending on that. There is big connections for the motor, plus and minus, and big connections for the battery, plus and minus. There are two connections, these two, which use a network cable, but it's not actually a network. It's actually a connection to a programming panel and to a data logger. This is the throttle cable, and it's the one I'm having trouble with when I connect my accelerator up to it. It gives me a fault code. And then this is everything else. So these two go across the pre-charge resistor to tell when the capacitors have almost been fully charged. That's when it brings in its own contactor, which is part of this. There are signals for a brake. There's an ignition lockout. There's 12 volts coming in. There's a variety of signals in there. Anyway, probably too much information about that one, but this is the Netgain controller. It is also liquid cooled. I should probably show you that. So the copper pipe coming out here is, and I don't know which one's in and which one's out. That's marked on the bottom. But you circulate coolant through here and run it through a radiator or however else you're gonna cool it off, just like a regular car. This is the 2006 Honda Civic accelerator pedal with its connector on the side, and we have the pin out for what each of these wires does. And one of my tasks is to get this connected up to the controller in such a way that it does not cause faults on the controller. So back to this view. The high voltage and low voltage junction boxes will ideally go in here and in here. We ran into version 1. We ran into trouble where first of all, the motor module was too tall because we were using a bolt-on, and we had an inch and a quarter taller than a regular motor module. And then on top of that, I put the high voltage junction boxes directly over the motor and the transmission, which the cases that I used, the transparent cases, were just storage containers from, I think they were Rubbermaid. They were sticking out on top of that as well. So I know that we have no clearance on top, so we're going to be strapping it to the bottom edge of these tubes if they fit. The low voltage is shallower, so I was going to put it on this side. The high voltage is deeper, we'll put it on that side. And the high voltage goes directly down to these terminals, so it's a nice short distance for the cabling. The batteries will be over here, and I can't fit all of the batteries right now. What I'm going to put in is as many as I can fit. I want to run a couple more tubes across here, a couple of verticals, and get the batteries in there with, I can only use wood. I would like to use aluminum, but I don't have aluminum sheeting that's strong enough to give me the structure I want. So I'm probably going to end up using plywood across the side and the bottom. Put a bit of insulation inside so that the batteries, if they are warm, they continue to be warm during most of the test. And the battery charger is going to be sitting on top of the batteries, about here. Okay, apparently I haven't talked about the axle yet. So these are the welded version of the axle. You can see the welds fairly plainly. The welded version is a little bit more difficult to take out of the car. You essentially have to take the wheels off, take the axle out of the transmission, and drop the transmission oil. Not something that takes something that takes much longer than changing the tire. And that's our goal, is to get the motor module to be changed in the length of time it takes to change the tire. I also haven't talked about where the controller is going. So the high voltage junction box is going in this area, so is the controller. So the controller can come over here, or over there, or just above the motor. I haven't really figured out exactly where, which is going to be on the top, which is going to be on the bottom. I think the controller is going to be on the bottom because you don't really need access to it once the car is put together. The low voltage junction box is going here for sure. And then there's a fan that I would like to put on here. I've got a blower. It blows cold air, or blows ambient air into the motor, because the motor doesn't really have any way of getting rid of heat, and accelerating does heat up the motor pretty good. I needed a little radiator to get rid of the heat from the controller, and I don't know exactly where to put it. This space and this space are the two candidates. I don't want to put it way up the front because that's right behind the cabin for the car, and there's really not a lot of airflow there, as I think we're finding out with the gas version of the WIKISPEED car. I think the radiator's up front as well. They're having trouble with the radiator being up front as well. So connectors. If you're going to remove this motor module from the car in a short time, the connectors have to be fairly easy to disconnect and readily accessible. So the locations that are fairly accessible, with the aerodynamic shell of the car off. I don't think anything is really very accessible with the aero shell on. With the aero shell off, we've got this side, we've got the top edge here, and we've got this side. So I guess I'm gonna try putting the connectors along this edge, and this edge, and I'm gonna try and split them up. Most of them are going to be flat bore trailer connectors, so they're going to be capable of carrying several amps of current. I'm going to be putting a smaller connector that's pretty close to the similar style for the accelerator and the brake, and I can't remember, maybe the dash, to drive the fuel gauge and stuff. I also have to come up with some connectors for the accelerator and the speedometer, the tach, that kind of stuff. I'm hoping they're all going to be separate small connectors, so that I don't get into polarization issues and that kind of stuff. The choice of those is still yet to be determined. Splitting them up, I was going to look for the lighting on the side, general power, high voltage, low voltage junction box signals, and then the accelerator, brake, dash on this side. But that's tentative. We'll see what ends up happening. These connectors aren't really well accessible unless the axles have been disconnected and you're actually pulling the motor module out. So you're sliding it out that way. The other option for taking the motor module out is vertical, so taking it up. If you take it up Of course, these connectors are fine. The ones on these sides aren't going to be as accessible, but again, it will work. It's just it's going to take a little bit more time. To highlight the things that I could use some help on is the shifter for the transmission. So we've got a pivot point here that might be able to be controlled by a servo or a cable. And then this movement back and forth on the transmission, again, a separate cable, I'm thinking, or an actuator of some sort. If it's electric, it works better just because you have a connector. If it's mechanical, then some way of disconnecting and reconnecting the cable has to be done. The hydraulics for the clutch, again, if we can come up with an electric something in the front of the cabin, and it comes back here as an electrical signal, and we can actuate a plunger to engage and disengage the clutch, that would be awesome. I don't know how to do that, and I don't know if anybody else does either. Radiators with fan. Passive radiators and the airflow don't seem to work very well. They don't work well for testing at low speeds for sure. So if I'm putting in a little radiator here with a fan, placement would be, I'm going to have to place that, I'm going to have to place a fill container and a pump. So mechanically routing that stuff around and what tubing to use and an available fill bottle with a cap and that kind of stuff. I look at Summit Racing and I see dozens of different options and I have no idea which ones are better or worse. Any suggestions would be welcome.